doing today is our first homework problem on calculating the formula of a hydrate. And this is from page 349, number 152, and we're starting with the given and the find. So if you look in the book, you'll find that 85.3% is our percent of the barium. Now, this is supposed to be barium chloride. What is the ratio of barium to chloride ions? Barium is number 56, so what's its charge? 2 plus, excellent, because it's in column 2. And what is the charge on the chloride ion?
1 minus.
Why is it 1 minus? Column 17. Okay, so how many chloride dudes do we need to match the 2 charges from the barium? 2 of them. Perfect. Okay, so this is going to be Cl2. All right, and our percentage for water is 14.7. And this is our H2O. And anybody know what we're supposed to be finding? Formula and name of the hydrate. Okay? Now, with this type of problem, you need to think of percent as grams, and then it all works.
So 85.3 grams.
Very good. 85.3 grams of the barium chloride. Okay? Over 1. Very good. Who said that? Kudos for you. Yay. Okay. Now. All right. Now, how do we get the molar mass of this thing? Barium is how many? How many grams? 137. And how many of these bariums do I have in the molecule? 1. So it's just 137. How many chloride dudes? 2. Okay, so we do Cl2. Each of those is 35.5, 71. So we got 208, right? What? 208. 35.5 when you round. And then we double that. Okay? So that's going to be 208. Now, this is grams that equals 1 mole. Who goes on the top? Who goes on the bottom? Moles on top, yes. 1 mole of barium chloride on top, and on the bottom we have 208 grams of the barium chloride. Oops, that's Cl2. BaCl2, and that's going to give us our moles of BaCl2, barium chloride. And no, it's, well, we don't have the name of the molecule yet. We're just finding out the moles first. So first thing we need to do is calculate that. So we take our 85.3 and divide by 208, and that gives us 0.410. Everybody okay with that number? Okay. 0.410. So that's the 3 sig fix. No reason why we can't do 3 sig fix here. Okay, now the next one is going to be our grams of water, which is 14.7 grams of H2O. And this is very far from hokey, because if we had actual weights, our ratio would be this ratio. If I had 200 grams, if I had, let's see, this will add up to 100 grams. If I had 200 grams, these would both be double, right? But the ratio is always going to be the same, because that's what we'll come up with in the lab. Now, next thing we do is molar mass of water. H2 for 2, or 2 hydrogens, 1 each for 2. And then our oxygens, we have 2 times 16, 32. And we have, why do we have 2? Oh, we have 1 oxygen. Oops. Oh, shame on Mr. Wigger. Okay, so we got 16, you're right. And that's a total of 18. Yep. Okay, we're good? All right. This is actually 18.0. I didn't put the decimals in, but I wanted to have 3 decimals, and this is very, very close to 18.0. And this is grams, H2O. Why is the water on the bottom? The grams on the bottom? Grams has to cancel. Okay, up here, I should have done this. Okay, cancel the grams of barium chloride, and we're left with moles of barium chloride, which is our answer for this calculation. And now up here, what do we have? 1 mole of barium chloride. Oops, water, thank you. You're keeping me honest. Okay, I was getting distracted a little bit here. Just got to make sure we don't go over on time. And that's going to give us what kind of number? 0.817. Okay, 14.7 divided by 18. And 0.81 what? 0.81 what? 7. Yes. Rounding. 0.817, and this is moles of H2O. Okay, now look on your data sheets that you're going to do the calculation on tonight, and who is going to be on the top of this last calculation? H2O. Good. So we have 0.817 moles of H2O, and we're going to divide that by 0.410 moles of barium chloride. Now, look the way this works out. The moles cancel, and we're going to have our ratio of water to barium chloride. That's what the ratio is going to be. When you run the numbers on your calculator, it comes out to 1.99. At least it should. And this is our moles of water. Okay? And for getting this ratio, we're going to divide this is the ratio. And this will round to what number? 2. So it's barium chloride. This big thing, the big circle here, is always part of a hydrate. And we have 2 waters. And so our ratio of water to barium chloride is 2 to 1. And now what's the name? Barium. Okay. Barium chloride. Yes, I heard it. Barium chloride dihydrate. There you go. So here's our formula. Yes. There's the name. Now, you look at this, and it looks like a lot of calculation, and I guess it is, but this is all real familiar ground for you guys. And the other neat thing is, when you compare this to what you first thought this looked complicated, okay, this is actually a little bit simpler. Isn't that simpler to look at and see? Yes. Just a minute. I need to stop this.